All right, welcome back to the Lumberjack Lawyer lesson. We're looking at the laws of logarithms. Before we get into logarithms, though, we want to be looking at getting your exponent laws all down. So let's just remind those. Let's do these a couple times here again. So 2 to the 5 times 2 to the 3. We're multiplying like bases. If you're multiplying, we add the exponents. So that's 2 to the 5 plus 3, which is 2 to the 8. When we're dividing like bases, we subtract the exponents. So let's do that. So we've got 3 to the 8 minus 2. We've got 3 to the 6. Dividing, same thing. Subtract 7 to the 3 minus 6, but this time we've got 7 to the negative 3. If we have a negative exponent, that means take the reciprocal of your base, so 1 over 7 to the 3. Or you can say it as 1 over 7 to the 3. Power of power. In this case, we're going to multiply the two exponents together. 7 to the 5 times 2, which is 7 to the 10. Now, as we move into the logarithms, a logarithm is just an exponent. So the exponent laws that we just talked about here are going to have to somehow apply when we move into logs. Let's look at how that happens. So playing around and pausing here and playing around for yourself with this is really beneficial before I start talking, because if you can learn it, you'll remember it much better yourself. But using the exponent laws now, let's try to figure out how do the log laws apply. If we've got logarithms, and they're both the same base, because we've got a base 10 and a base 10. We don't have to write the 10 if it's a common log like that. So if we're adding them together, remember, logs are exponents. If we're adding the exponents together, that must mean that we were multiplying. So log 2 times 3, or log of 6. Now you can punch that into your calculator and you will see, hey, those are the same. Log of 8 minus log of 2. Again, looking at the exponents, if the logs are exponents, if we were subtracting the exponents, we must have been dividing. So that's going to be log of 8 divided by 2, or log of 4. And then a 3 log 2. If we were multiplying in our exponential form, we must have had power of a power. So in that case, here, we're going to be looking and saying, well, wait a minute, we could actually say, I've got 3 of log 2s. So that means the same thing as saying log 2 plus log 2 plus log 2. I've got 3 of them. That there, using the multiplication law that we just saw in the first one there, would have been log of 2 times 2 times 2, which is the same thing as saying log 2 to the 3. Oh, look at that. This 3, was what was multiplied in front. Interesting. Or log of 8. So I've just led you through 3 of the laws that we're going to be using. First one, the product law. If we're multiplying inside of the log, we will add the logs together, because the log is just like the exponent. So if you're multiplying like bases, you add the exponent. Careful here, we're multiplying inside of the log, not multiplying 2 logs together. It goes from 1 log here to 2 logs here. Quotient law. If we're dividing inside of the log, we go from 1 log to 2 logs where we subtract. So dividing goes to subtract. And then power law. Again, inside of the log, 1 log, we are now bringing that exponent down and multiplying in front. And these 3 laws are on your formula sheet in that order. So it's not something you have to memorize. You just have to be able to know when to use them and how to use them. And let's try that out and see if you can use them. And there's your lovely bit.ly link. Check it out there. Which one of these is not equal to that? Try that one out now. And while you're there, we're going to be doing the second one right now, right off the bat. Which expression is equal to this? So you got 2 to do right there. Let's go and look now at our product law. And let's look at the proof behind it. Why is this true? So first step that we're going to do is we're going to say, hey, let's let log base b of x equal m. And let's let log base b of y equal n. Take it from there. This is the log form. Let's change them into exponential form. The base stays as the base, the b. We switch the x and the m from the sides. Same with the y and the n. The base is the b, the y and the n switch sides to go from exponential and logarithm form back and forth. So there's our first move. So now if I wanted to go and say, hey, let's multiply x and y together. So x times y is the same thing as multiplying the other side. X, because x is b to the m, and y is b to the n. So x times y is the same thing as b to the m times b to the n. Now let's use our product rule for exponents. If we're multiplying like bases, we add the exponents. And now we've added those. And let's take it back into an into a logarithmic statement. So we've got it in an exponential here. Let's go back into a log statement, which means the base stays as the base. Log base b, and the x, y, and the m plus n have to switch sides. So the xy goes with the b side, and the m, n that were on the b side are now going over to the other side of the equation. Well, wait a minute. We just said that m was equal to log base b of x, and that n was log base b of y. So let's fill those in. The other 2 proofs you're going to be working through yourself so you can see how they work and where they come from, and to practice that, the use of those laws all the way through. Now you're very lucky that you've got access now to electronic calculators, and you've got all the logs stored in there. And like I said before we had the electronic calculators, people would use log tables. And it would have all of what's stored in your calculator on a big table, and you'd have to find, okay, what's the value of log of this and log of that. Which leads me into a little bit of a story before we get started here. A friend of mine, quite a number of years back, he was walking in one of the national parks there, and he noticed the 2 snakes. And they slithered by, and he said to these 2 snakes, this male and this female, he said, "Hey, where are all the little snakes?" And Mr. Snake replied, "Well, we're adders, so we cannot multiply." Well, the following year, my friend, he went back to the same spot there for camping, and this time there's a whole bunch of little snakes. And he turned to Mr. Snake there and he said, well, I thought you said you could not multiply. And Mr. Snake, he says, well, the park ranger came by and he built a log table. So now we can multiply by adding. So keep that in mind. You can multiply by adding when you use the logs. All right, so let's pound through some of these real quick here. First thing, if we've got two logs, we can simplify them. That often will be said, they'll ask you to put it into a single log. So we can take this into one single log by, if we're adding logs, we will multiply within the log. Make sure you do not put log of 7 times log of 8. This is not correct. We are multiplying from two logs, we are taking to a single log, and the log of 7 times 8. And then we'll just leave it as log of 56. You could punch that into your calculator. The way you would do so to verify with the calculator is you punch log of 7 plus log 8. So log of 7 plus log of 8. In your calculator, you get 1.7481, dot, dot, dot. If you plug log of 56 into your calculator, you'll also get 1.7481, dot, dot, dot. So that's right there, that verification, that's a great way to use some of your multiple choice questions. Okay, so let's go to the next one. B, 5 log of 2. If we're multiplying, that means we add a power of a power. So that 5 can go up as an exponent. This can only be done with logs. Don't start saying, hey, I could just put anything up, a coefficient up as an exponent. Only works for logs. Log is 2 to the 5. Sorry, log of 2 to the 5. Which gives us log of 32. And again, verify that. Punch it into your calculator. 5 log 2. That gives you 1.5051, dot, dot, dot. Don't just write it down. Take out your calculator. Try this. I can do it. Can you? That's what's more important. Find your errors now before you go too far. Got to know how to punch these into your calculator correctly, especially with brackets and stuff. So log of 32, make sure that you get 1.5051, dot, dot, dot. Log of 80 minus log of 16. We are subtracting 2 logs. That means we are dividing in one log. Get it to one single log. Log of bracket 80 over 16. And this can only be done if those bases were the same, and they were. They're both base 10. 80 divided by 16, that is log of 5. And again, let's verify this baby up. So that would be log of 80 minus log of 16. Punch that into your calculator. Make sure that you get the right answer of 0.6989, dot, dot, dot. Plug in log of 5. Also you get 0.6989, dot, dot, dot. Now here's where you're going to be more likely a question coming from on your diploma. They're going to throw X's and Y's in there. And they're going to say, write it as a single log. Because you can't just plug it straight into your calculator. Although there is some guess and check methods that I will show you. Oh, got to use our rules. Before you can use the multiplication, the product, and the quotient laws, we want to use the power law first. Even though it's going to be third on your formula sheet, that's the one we want to work with first. So in order to multiply them, we've got 2 logs, we got to make sure that we have coefficients of 1 in front. So the first thing we're going to do, get that 3 up. So we get log of x plus log of y cubed. Now we've got coefficients of 1 in front. You got 2 logs. Let's bring it together. Log of, we're adding, so we multiply. X, y cubed. Can't go any further. That's done deal. Let's go over to B. Same thing. Let's get all those coefficients up first. Let's take them up as an exponent. So log of x plus log of y to the 2 minus log of z to the 4. Now here's a little trick. If we're adding, we're multiplying. If we're subtracting, we're dividing. So when we have more than one going on here, do it this way. Start log bracket. If it's a positive sign in front of that log, put it on the numerator. If it's a negative sign in front of that log, put it in the denominator. So x, first one, x had a positive in front, goes numerator. The y to the 2 has a positive sign in front, numerator. But the z to the 4, oh boy, has a negative in front. That means going denominator. And then you look and say, can I simplify any of them? No, I got x, y, z, can't go any further. That's finished. Now, log base 2 of 6 minus 3. In order to use those rules, we've got to have two logs of the same base. I've got a log, and I got just an integer. So what am I going to do there? Well, first thing we're going to do, we're going to try to get 3 with a log attached to it. So a couple ways of doing this. The way that I'm going to show you is I'm going to say, we can always multiply something by 1, and it's still the same. So we're going to multiply 3 by 1. But I'm going to use a different form. Just like we can change the forms of fractions, or we can change the forms of radicals, we can change the forms of logs. And something that equals 1 is this. Log, we'll start with the base 10 of 10. This is saying 10 to the what is equal to 10? Well, 10 to the 1 is equal to 10. That equals 1. How about log base 5 of 5? 5 to the what equals 5? Well, 1. Log base 2 of 2. 2 to the what equals 2? Well, that's 1 as well. This is the one we're going to use here. So I'm going to take that and multiply it by the 3. So it's going to look like this here. Log base 2 of 6 minus 3 log base 2 of 2. Hey, I've multiplied it by 1, but I've got a base 2 log attached to it. So now I'm going to use my rule. But first, we got to take the 3 up as an exponent. So we got log base 2 of 6 minus log base 2 of 2 to the 3. Or in other words, log base 2 of 6 minus log base 2 of 8. If we're subtracting, we're dividing. So let's divide that puppy up there. Log base 2 of 6 over 8. Well, that's not lowest terms. It's sacred lowest terms. Log base 2 of 3 over 4. You can check that on your calculator, this one. Put in the original, put in your answer, make sure that you get the same for both. So now let's use it. Let's go the other direction. We've got a single log. Let's break it up into as many logs as we can. Because we want logs A's, logs B's, logs C's, with nothing else on those parts. So if we're dividing inside, that means we are going to subtract 2 logs. Log of A minus log of B squared. Okay, let's make sure, we got to do this no again, not. Common error with this, log of A minus B squared. No. We're going from a single log into 2 logs. We broke it up into 2 parts. So not this. It's a common mistake. Now, we're not done yet because we just want log B. Let's bring that exponent down in front. And again, you can only bring exponents in front on a logarithm. Log of A minus 2 log B let's try that next one. We've got more things happening. We've got A's, B's, and C's this time. If it's a numerator, positive sign in front. If it's a denominator, negative sign in front. So we've got log of A squared. B's in the numerator, so plus log of B. And that looks like a 1/3 to me. B to the 1/3. C's in the denominator, subtract log C. Now look, we've still got some exponents. Let's bring those down. So 2 log A plus 1/3 log B minus log C. Finished. And before we get to the last question here, I know you all are thinking, hey, we haven't been able to listen to that guy who talks and explains things to us. Well, here you go, just for you. We're going to listen to Buddy talk.
Part A. Evaluate 2 log base 2 of 6 minus log base 2 of 9. The power law says that n log base b of x is equal to log base b of x to the power of n. For 2 log base 2 of 6, n equals 2, b equals 2, and x equals 6. So, 2 log base 2 of 6 can be written as log base 2 of 6 to the power of 2. I can simplify 6 to the power of 2 and write log base 2 of 36. The quotient law says that log base b of x minus log base b of y is equal to log base b of x divided by y. In this case, b equals 2, x equals 36, and y equals 9. So, I can write log base 2 of 36 minus log base 2 of 9 as log base 2 of 36 divided by 9. This equals log base 2 of 4. I want the base of my logarithm and the base of my power to be the same. I can write 4 as 2 squared. Since the base of the logarithm and the base of the power are the same, I know that the answer is 2. So, 2 log base 2 of 6 minus log base 2 of 9 equals 2. Part B. Evaluate log base 9 of 2 plus 3 log base 9 of 6 minus 4 log base 9 of 2. First, I'll use the power law. For 3 log base 9 of 6, n equals 3, b equals 9, and x equals 6. So, 3 log base 9 of 6 can be written as log base 9 of 6 to the power of 3. For 4 log base 9 of 2, n equals 4, b equals 9, and x equals 2. So, 4 log base 9 of 2 can be written as log base 9 of 2 to the power of 4. 6 to the power of 3 is 216. 2 to the power of 4 is 16. The product law says that log base b of x plus log base b of y is equal to log base b of x times y. For log base 9 of 2 plus log base 9 of 216, b equals 9, x equals 2, and y equals 216. So, log base 9 of 2 plus log base 9 of 216 can be written as log base 9 of 2 times 216. Now I'll use the quotient law. In this case, b equals 9, x equals 2 times 216, and y equals 16. So I can write log base 9 of 2 times 216 divided by 16. 2 times 216 divided by 16 is 27. I need to write 27 as a power of 9. 27 equals 9 times 3. I can write 9 as 9 to the power of 1, and I can write 3 as 9 to the power of 1/2. Now I can add the two exponents, so 9 to the power of 1 times 9 to the power of 1/2 is equal to 9 to the power of 3/2. Since the base of the logarithm and the base of the power are the same, I know that the answer is 3/2. So, log base 9 of 2 plus 3 log base 9 of 6 minus 4 log base 9 of 2 equals 3/2.
I know you missed having that, so there you go. We're going to look at ours. And I know you might also be saying, hey, why did I just punch the original into the calculator and get the answer? Well, if it's a multiple choice question, go ahead. But if it's written, you got to show your algebra. You also have to be practicing the algebra skills here so that you can do the more difficult problems, especially when they start throwing x's and y's at you. So it's a process to make sure that you understand the algebra behind here. So let's go through evaluating this one. Let's get to an answer at the end. So we got first move, let's plop that coefficient up. So we got log base 9 of 6 to the 3 minus log base 9 of 7 to 2. 6 to the 3. That's 216. So log base 9 of 216 minus log base 9 of 72. We're subtracting. Let's divide. Taking it from 2 logs into 1 log. Log base 9 of 216 over 72. Dividing that gives us log base 9 of 3. And now we're saying, hey, 9 to the what equals 3? Well, we know that the square root of 9 is 3, so that means we've got log base 9 of 9 to the 1/2. Exponent of 1/2, that's the same as square rooting. So 3 is the square root of 9. And that's what they're saying, square root of 9. Meaning the same thing, and that's 3. So at this point we can say, hey, I can bring that exponent down in front. That's 1/2 log base 9 of 9. Log base 9 of 9 is 1. So we've got 1/2 times 1. That's 1/2. There's your answer. Let's go to the next one. First thing is always is being here. Let's take every one of those coefficients up. And here we go. So we got log base 4 of 6 to the 2 minus log base 4 of 3 to the 3 plus log base 4 of 12. And the little trick I showed you. If it's positive side in front, numerator. Negative sign, denominator. Please be careful again that you are not dividing logs. You're dividing within the log. 1 log, write her down, log base 4, bracket. This can only be done if all of the bases are the same, and they are, that every base here is 4, 4, and 4. Good. So now, numerator for the first one, what's a positive sign in front? Negative sign in front of this next one, denominator. Positive sign, numerator. And let's clean it up. 6 to the 2, that's 36. Multiplied by the 12. Over 3 cubed, that's 27. Okay, so 36 times 12 divided by 27. You can either use your calculator or you can try to reduce that yourself. It's a really good thing to try to reduce this without punching into your calculator, like going through and saying, okay, I know I can divide 27 and 12 by 3. So hiya, that gives me a 9 and that gives me a 4. But hey, I can divide 36 and 9. Those go nicely together. So let's divide that. So 9 divided by 9 is 1. 36 divided by 9 is 4. I'm now left with 4 times 4. We got log base 4 of 4 times 4, which is 16. But in this next point, we're saying 4 to the what is 16? And I know 4 squared is 16, so my answer is going to be 2. But I could also look at it as doing it this way. Log base 4 of get 16 to a base 4, 4 squared. Let's bring our exponent down in front. So we get 2 log base 4 of 4. Log base 4 of 4, that's equal to 1. So now we're looking at 2 times 1, which is 2. So a few ways of thinking it through to get to the same answer. Very important question here. Let's relate your log laws into your exponent laws. How are they related? That way you can kind of remember back and forth a little bit. Even though the exponent laws are not on your formula sheet, you can use your log laws to find your exponent laws, or vice versa if you need.